For today's lesson, we're going to be talking about what are variables in math. And so typically in math, when we're talking about variables, we're talking about a letter that will stand in for an unknown value. So for example, we could have the problem blank or something plus 8 equals 15. And we could go ahead and solve this by saying, well, what plus 8 equals 15? If I work backwards, 15 minus 8, and I'll get the value in the blank space. However, instead of having a blank, I can use a variable. In this case, I've chosen the letter x as my variable. So I'm saying x plus 8 equals 15. All I've done is I've replaced the blank space with a letter. It's the same exact thing though, and I would solve the problem the same way. I would say, well, I don't know what x equals, I don't know what the blank equals, but if I work it backwards, 15 minus 8 will tell me what x has to equal. And so if I solve it out, I can see that x equals 7. Now, in this particular case, my variable x can only equal 7. There's nothing else that I could plug in for my x value to make the equation work correctly. I can't say that x equals 100 because 100 plus 8 doesn't equal 15. I can't say that x equals 1 because 1 plus 8 doesn't equal 15. The only thing that x can equal in this case is 7. There's another way that we can use variables as well, and that's to represent patterns, where the variable could equal any number that we plug into it. So let's take a look at an example of that. Let's say I have these three problems here. 5 plus 0 equals 5, 10.7 plus 0 equals 10.7, and 150 plus 0 equals 150. There's a general pattern occurring in each of these problems. We notice that I add 0 each time. That's something that doesn't change. It's constant throughout all of these problems. We also notice that whatever number I start with, that is my answer. 5 and 5, 10.7, 10.7, 150 and 150. So I could replace each of these numbers, the things that are changing from equation to equation, this first number, that's what changes. The 0 is what stays the same. I could replace the number that changes with a variable to write a general statement about it. And in this case, I could say, whatever the first number is, I'm going to replace that with a variable x. I'm going to add 0 to that, and whatever this number is, if I add 0, I'm going to end up with the exact same number. So x plus 0 equals x. That's a general statement about the pattern that we see in these three problems. Whatever this number is, x plus 0 equals x, or whatever I started with. So in this case, I could plug in any number for x. X doesn't have to be 7. It could be 100. It could be 5 billion. It could be anything. Anything plus 0 is going to equal itself. So let's look at another example here. I have 6 minus 6 equals 0. 1/2 minus 1/2 equals 0, and 1253 minus 1253 equals 0. So again, we can look and see what changes from equation to equation or problem to problem, and what stays the same. Well, from problem to problem, this number changes. I went from 6 to 1/2 to 1253. And same thing here. I'm always subtracting, that didn't change at all, and the answer always equals 0. That didn't change either. So I can replace the thing that changes in each of these problems with a variable. Now so far we've looked at variables as being the letter x, but we could actually use anything as a variable. Typically we are going to use a letter, and so that's how I'm going to demonstrate it, but I'm going to choose a different letter this time, and I chose n. So we could really use any letter we want. It could have been B, it could have been Y, whatever. So if we think about the pattern from those three problems, we see that we have some number minus that same number, and it equals 0. And if we look back again, we can see that some number minus that same number equals 0. Some number minus that same number equals 0. Now all we've done is we've replaced the numbers with a variable, And what this variable tells us is that I could plug in any number for n I wanted. This could be 1 million minus 1 million, and it would still be true. It could be 7 minus 7, and it would still equal 0. So we could really use any letter we want as our variable, and this statement would still be true.